All right, so from chapter 5, what we're going to review is the if statement, the Boolean expressions, comparing data, and the while statement. We didn't really cover any of this stuff like the iterators and the array list, but it's something we're going to talk about in Java 2. So I'm not going to cover it now. We'll just go, like when we're done reviewing, we'll just go back to it. And from chapter 6, the switch conditional operator, which is the ternary operator with the question mark and the colon, do statement and the for statement. And we didn't talk about any graphic stuff in Java 1. Okay, so I'm just going to just do examples to kind of go over each one. But a lot of them are similar to any other programming language. Like most programming languages have the same types of loops and condition statements. All right, so the first one is if. Let me just actually bring up Notepad++. All right, so under simple demos, I'm going to have one called like if demo. And this is where programming, at least in my opinion, like started getting fun because you can actually write programs that aren't linear, like they're based off of certain conditions. So public class if demo, public static void main string array. All right, so the if is actually pretty simple. I mean, really it's just if, and then inside the parentheses you have some Boolean expression, so something that evaluates to a Boolean, and if it's true, then you're going to execute whatever's in there. If not, you're not going to execute, right? So you can have something like int, num1 is 7, actually we'll make it 8. And then we'll come here and say, if you take num1 and you divide it by 2, and the remainder of the division is 0, then you can say something like it's even. You can say system. You could say the number you entered, and we'll just say like num1 is even. All right, real simple program. I'll hop over to, let's see, where am I? Dang it, I went up 3. Should I went up 2? What the heck? I'm using the wrong. All right, so I'm going to compile and then run. All right, so 8 is even. Okay, if I come over here, change it to a different number like 5. Then when I go to compile and run, right, there's no output. Okay, there isn't any output because this condition was false. Right, I divided by 5 by 2, and the remainder was not 0. So no statements were actually executed. If I wanted to execute a statement, like a default, then if I try to divide you by 2 and there's no remainder, you're even, and then the else case would be odd. So now I come over here, play my screen, compile, run. Now it says 5 is odd. Right? Before it didn't say anything. So you check the condition. If the condition is true, you execute this statement. If it's not, then you execute this statement. Now you can also have excuse me, another condition that you check as part of this if. So you can add in an else if. Now I don't know, but I think maybe 0 isn't technically even. Do you guys agree with that? Since it's nothing, right? Or I don't know. Is it 0 even? I have no idea. It's been a while since I've been in math.
What is the definition of even?
I don't know.
Is
But let's just say,
0 by 2. Can you divide 0 by 2?
yeah,
Then
or no,
the-
can you? Though,
Yeah,
because then like that means nobody gets anything.
Yeah.
Can you divide? Can you really divide something that there's nothing of? I don't know.
Well, I mean, technically, you can divide anything by 2.
Yeah.
So
Yeah.
you're saying that 0 is not an integer.
Yes.
So, I mean, we'll say this. We'll just say I want to know if it's odd, even, or 0. 0 might be even. I don't know, but like if it's 0, I just want to know if the value is 0. So I'm going to change this up a little bit. We'll say if num1 is equal to 0, then I'll just say num1 is 0. Then I could just slap in what I had up above, where I checked if you divide num1 by 2 and the remainder is 0, then I can say num1 is even. I'll say is even and not 0, so we don't make any false claims, right? And then here on the else condition, I'll just say is odd. Okay, so now I have two conditions I'm checking. They're all part of the same statement. So if this is equal to 0, then I'm going to just print out num1 is 0. Okay. If I divide num1 by 2 and the result of that is 0, I'm going to claim that num2 is even and not 0. And if any other condition, I'm going to say the number is odd. All right, and I'm going to, let me make this, let me use the scanner class so I don't have to keep compiling. Say import java util.scanner. Let's say scanner, scan is new scanner. All right, and then what I'm going to do is prompt the user for a number. I'm going to declare int num1 up here. I don't know, it just bothers me that it's down here. All right. Okay, so now when I compile, I'm enter number, I'm going to put 0, and 0 is 0. Okay. Run it again. This time I'm going to put 80. 80 is even and not 0. And then run it again. I'll put negative 9. Negative 9 is odd. Yeah. All right. So this is an example of the if. The other thing from chapter 5 was the while, I believe. But we also did comparing data. Dang it. All right. So I can use a while statement to keep something going. So for instance, I can do what we call, what the book refers to as a sentinel value, like just some value that you ask the user to enter so that you know you want to stop a loop. So I'm going to go ahead and wrap what I did here in a loop so I can keep entering numbers. So I'm going to ask the user, enter a number or -1 to quit. Okay. Now I have to come up with another condition here, right? I have to say if num1 is equal to -1, then I want to quit. I want to say, I don't know, say something like this: system out print line. Goodbye. Just something to like let them know the program ended, and I need some type of way of ending the loop. So what I'm going to do is I'm going to wrap all of this in a while loop. So while kind of works the same way as the if, where inside of these parentheses is statements you're going to execute, or not parentheses, I'm sorry, curly braces are statements you're going to execute. So I'm basically saying I want to execute all these statements inside of this while loop until some condition here becomes false, right? So all I'm going to do is I'm going to make a variable to control this loop. I'm going to make it a Boolean, and I'll just say Boolean, well, I guess over, I don't know, is over, is ended, program ended, continue, I don't know. I think of a good name. I'll put end loop. We'll call this one false. Okay, so I started off by making this Boolean false, so I'm going to use it to control this loop. So what I'm going to say is, if like this loop will only execute if this condition here is true. Starting off at false, so I technically want the not of this, which is the exclamation mark, which just gives me the reverse of whatever the Boolean value is. So if it's true, it gives me false. If it's false, it gives me true. So I'm basically saying, while we're not going to end the loop, keep executing this loop over and over and over again. Now, at some point, I have to set that value equal to false, or excuse me, true, so that we want to end the loop. And we'll do that when num1 is -1. So here I'm just going to say in loop is equal to true. Now this will end the loop. I'm going to go ahead and, I didn't finish these conditions. All right, so now I have 3 conditions I want to check, right? In 4 possible statements. I want to check to see if num1 is -1 because that's what I want to end. I want to check to see if num1 is 0 because I want to tell them num1 is 0. I'll check to see if I can divide num1 by 2. If so, I'll claim that it's even. And anything else, I'm going to say it's odd. Okay? So, and that's it, right? This is a while loop. This is a condition that controls it. It's going to execute until this condition becomes false. The while loop, however, there is a possibility that the while loop will execute 0 times. If I actually set this value to true here, then not true would be false, and the loop will never execute. Right? So if I just, for some reason, I messed up my logic, I came here, set it to true. When I try to compile this now, actually it will compile, but when I try to run it, it's just not going to do anything, right? It just ran, but immediately it saw that in loop is true, so not in loop was false, meaning it never actually executed any statements inside here, like not one time at all. Now if I change this to false, like the way that I had it before, then this is true initially, and the only time it gets set to true to stop the loop is when I enter in a -1. So I'm going to compile and I'm going to run. I'm going to check to make sure I can actually end the loop by just typing in -1. It does work, awesome. Now I can go here and I just keep entering numbers. I enter to 0, right? And I put 0, like 0, 0. I enter in 8. 8 is even. 88 is even. 100 even. Now if I enter in some odd numbers like 9 and 25, -2, right? It's not until I enter in -1 that the loop actually stops, right? Because I was controlling this condition with this variable right here. And I know some people do things like, well, if you ever get to this point, then just break right here and then make this true, but that's actually considered bad programming practice, right? You're basically making an infinite loop, but the only way you're going to break out of the loop is when you type in break. This will actually work just the same, and you don't need that in loop there, but doing stuff like this is just kind of like a hackish way of getting this loop to work. So, right, and it'll work just the same, right? So if I enter -1, it stops, and I can enter in a 0, I can enter in even numbers, odd numbers, and then when I enter in -1, it ends the loop, right? It worked the same, but it's kind of a hackish way of doing it. You should just set up some type of condition or some type of variable to actually control ending this loop. Any questions on that? That was chapter 5. Some other things from chapter 5 is comparing data. I don't remember what was talked about. I'm going to have to click on it and find out. Oh, so okay, so floats. I remember now. Comparing. All right, I'm gonna just do another example. Yeah, So come over here, new file, and save as. All right, I'm going to use the scanner class. All right. Let's see. So whenever you're comparing like floating point values, that'd be really careful because if it's not the exact binary representation of each other, then Java is going to say they're not equal to each other. So for instance, I can prompt the user for two floating point values, say enter a number, so like right here I'll have double, num1, num2, num1 will be equal to scan dot next double. All right, and then from here, I'll say something like, okay, well, if num1 is equal to num2, then system out print line, shit. Numbers are equal. And the else would be all right, and I'm going to compile and run. All right, so I'm going to turn like 1.17 and then 1.17 0001. All right, and like because those numbers aren't the exact same binary representations of each other, the Java considered them not to be equal. But like for tolerances and stuff like that, like for I don't know whatever math that you're trying to do, like maybe perhaps like if it's that close that you want to consider them to be equal to each other, right? Even something like 0.000001. How many zeros is that? 6. And then 0.000000999. Right? Those aren't equal to each other, right? So like they're like fractions like apart, and perhaps you're doing a program where you don't care about precision that deep. So what you can do is there's several things you can do. But I think the easiest thing to do is to create like a tolerance of how close you want them to be. So because it's constant, I'm going to use the final modifier to make it constant. I'll say final double, let's see, tolerance. And I'll say as long as they're within 0.001, what is that, tenths, hundredths, thousandths, as long as they're with thousandths of each other, then I'll just consider them to be equal. So then what you can do is you can use the math class, which we talked about in chapter 3. The math class has a method called absolute value, where you can just take the diff of num1 and num2. Doesn't matter which one's greater or less than because you're using absolute value. And you can make sure that the result of the difference is less than or equal to whatever your tolerance is, right? And then you can say numbers are effectively equal, right? So now now we have a tolerance of 1,000. So as long as they're within the 1,000th of each other, then we'll consider them to be equal. We'll compile, and we will run. Dang it. Run. All right. So I'll just say like 1.432. Okay, and this one will be 1.431 9999. I think that should work. All right, so they're close enough to each other to be equal to each other because our tolerance is just 1,000ths, right? And the difference between this is, I don't know, like, I can't do that in my head. I'm sorry, like 0.000 1, right? 0.000. Yeah. Anyways, they're close enough because it's less than the tolerance of 1,000th. Right, any questions on that? Some other things that for comparing data is you have to be careful with objects, because objects, they basically, when you compare objects, you're checking to see if it's the same object in memory. Let me make a new example called comparing objects. All right, so I'm not going to ask for data. So public static, public class, name of my class. All right, and from here, what I want to do, let me see what objects I have in this folder that I'm in. I know I have to have something. For the die, okay. Let's see what I did for die. Do I have an equals method? Okay, so I did define an equals method on this die class. That's good. I'm gonna go ahead and bring that up. And we're gonna talk about comparing data with objects one more time. So we have a die1 is equal to new die, and die2 All right, I think I have a toString defined. Let me find out. I do. Okay, perfect. So what I'm going to do is just print these objects out. And it's going to tell me like what their values are. So I am instantiating the objects, and then I'm just printing them out just to see their initial state. All right, they're both have a face value of 1. Okay, now when I try to actually compare them using the equality operator, oh, did I? Oh, dang, what the heck, thanks. So everything I just told you is for nothing, but all right. I'll say objects are the same. The else case would be all right. Hop back over here and compile and run. Okay, so it's telling me objects are not the same, even though their face values are the same. So what's happening here is Java is checking to see if these two objects are the exact same object in memory, right? So using the equality operator on objects is not actually, you're not actually checking to see if, you're not actually calling this equals method, which this equals method on the die class is checking to see if the face values are the same. Okay, so whenever you compare objects, you have to invoke the equals method. Now, to make this actually true, let's just say that I'll make an alias. I'll say like die3 is equal to die1. Okay, now I have two object reference variables pointing to the same object. So die1 points to an object in memory, right? And now I'm making die3 point to whatever die1's pointing to. They're both pointing to the exact same thing. So now if I were to...
You have to substantiate the die3.
No, you don't. Because it's just an object reference variable. It's pointing to the same thing that die1 is pointing to. So you don't need to instantiate die3 because it's just a reference to die1, and die1's a reference to the same object. Does that make sense? Like there's an object in memory, die1's pointing to it, now die3 is pointing to the same thing. With this assignment right here, you're basically just telling Java, I want die3 to point to the same object as die1. Right? So now because they're both pointing to the same object, now when I try to run this and I compare those two, then you'll see, dang it. You'll see that they're the same, right? Objects are the same, and the only reason that passed was because they're aliases of each other. They're pointing to the exact same thing. And to prove that, what I can do is to say down here, I can say system out println die1 face value, and I'll say die1 dot get face value. Dang, they mean to do that. Don't know what happened. All right, and this one would be die3. This one would be die2. All right, so what I'm going to do is I'm going to say, okay, die1 set face value, and I'll just set it to 5, okay? And you'll see that die3 is going to have the same value. And then what I'm going to do is I'll set die3's face value to 3. Actually, can I change it outside of the range? Did I put an if statement? Dang it, I did. Okay, so this is keeping me from setting it to something out of my range, but if I were to comment this out, that means I can set it to whatever I want, which kind of makes no, like, it kind of just makes no sense, because we're trying to maintain encapsulation by making this private, but now if I'm not filtering out that data, I can set it to whatever I want. So there's not any real encapsulation going on. But say die3, I set it to -777. Okay. So here I'm going to clear my screen and compile, run. You can see that here I rolled die1 like right after this statement, and die1 and die3 have the same base value. Die2 stayed whatever it was before, which was the default, and then I said I rolled, I didn't roll, I actually set the face value. Then I set the face value die3 to -777, and they both change, right? They're both pointing to the same object in memory, so they're called, that's what we call aliases of each other. Okay. Now, if you actually wanted to check for true equality, meaning all you cared about is if the face values are the same, then whatever class that you create, you have to go and make an equals method for that class, like I did here, and determine what it is you want to compare. In this case, I just said if the face value is the same, I'm going to consider them to be the same. So if I come back to my code here and I change this if statement, okay, I'm going to, so like here is where I instantiate the two objects. They both have the same face value because I didn't roll them or anything. So before I actually do the comparison of the die1 and die3, I'm going to say die1 equals die2. This is going to call my equals method, which is going to compare the face values. I could say die 1 and die 2 have the same face value. Wait, have the same value. All right. All right, and now I'm gonna hop over here, clear my screen, compile, run. Okay, so up here you can see that die 1 and die 2 have the same face value because they were both 1 in the very beginning. Now I can put a while loop and like roll these a couple of times. Let's see. I'll just come up here, make a Boolean. I'll say stop. Dang it. All right, and then right here, what I'm going to do is say if, no, I'm sorry, while you don't want to stop your loop, then you're going to keep comparing die 1 and die 2. Okay, so what I'm going to do is I'm going to stop it if we get the same. I'll say stop loop is true if die 1 and die 2 are the same, but I'm going to roll die 1 here, and I'm going to roll die 2 here. So really, I'm only going to stop as soon as we get a match. Okay, that's what's going on like right here. Okay, and now I'm going to clear my screen, compile, run. Right, so I rolled this until I got a match, and once I did, I was able to break out a loop, right? So I should have printed out their value. Dang it, what was I thinking? All right, so where can I print these values out? I'll just say system.out.println string.format. I'll do a %d, %d, and then that will be die1 dot get face value, die2 dot get face value. All right, so I'm gonna print out this string that's just gonna tell me what their values are for every row. Wait, I did it in the wrong spot. Dang it. I should have done it right here before I go into the condition. And let me put a semicolon at the end and compile and run. Okay, so dang it, I'm gonna do that. So I wrote a 3-1, a 6-2, a 1-4, 4-1, and finally I wrote a 2-2, and that's when I said they're the same and I stopped. All right, so that's how you compare data for objects. So depending on what it is you're trying to do, you would set up your own equals method so that you can compare. Now maybe like there's plenty of, I have, like where I work at, there's plenty of classes that we never compare. So there's no need for me to go and add an equals method to that class, because nowhere in our code do we ever want to compare like certain things, right? But a lot of times when we do compare, we have like unique identifiers on a lot of this stuff. And a lot of times it's just checking to see if it's the same unique identifier. So if I'm going to compare two accounts in a bank and I check like their account number, if the account numbers are the same, I don't care what any of the information says in it, right? Because if the account numbers are the same, essentially it's the same account, right? Because the account number should never change, right? That's something that just stays permanent in our database, like unique in our database. So like if I have an object that I'm messing with, I have a reference variable here, and then for some reason I have the exact same object in some other place. If I'm going to compare the two, I'm not going to go down and check the account name, the city, the address, and all that. The only thing that matters to me is that account number is the same, right? Then I can say the two are equal, right? So depending on where you work at and what you guys consider to be equal, you make your own equals method, but there might not even be a need to make an equals method because there's a lot of things that we don't compare, so why would we need an equals method on it? Any questions on that? But it's important to note that whenever you compare objects, you're actually comparing if they're the same object in memory. Let me hop over here really quick because I kind of think there's some important stuff that I might have skipped that it's good to know. So in Boolean expressions, what's actually good to know is the different checks that we can do. So you can check for equality, you can check for it's not equal to, you can check for less than, greater than, less than equal to, greater than equal to, right? This is pretty standard across programming languages. There's also the and, the or, and the not, somewhere, the logical operators. You can not any Boolean expression, meaning you can get the reverse of whatever it is. You can join two expressions by using the and you can join two expressions by using the or, meaning if one of the if one expression or any of the expressions on either side of this is true, if any one of them are true, the whole thing will be true, right? Where the and is both have to be true on each side. So if you look at this truth table, right? You're saying if A is true, right? If A is true here, it's false, false, right? B true, right? So just saying A is true and B is true, then A and B is true. A or B is true. If A is true, excuse me, A is true and B is false, then A and B is false, right? But A or B is true, right? Because A is true, right? And then if you have A is false, B is true, then A and B is still false, right? Because they both have to be true. But A or B is true. And the last one, if they're both false, then A and B is false, A or B is false. Yeah, but that's pretty, I mean, I don't think I don't know. I think every programming language has the and the or, but I don't know what annotation. I think some languages use like actual and or spelled out, but I think like C++ and Java, C#, all use this annotation. The ampersand and the pipe, vertical line, whatever you call it. All right. That was stuff that you should know. I think that was it for chapter 5. You see. Yeah, we talked about the while statement, we talked about the if statement, comparing data, and the Boolean expressions. Now, chapter 6, we'll talk about the switch, the conditional operator, the do, and the for. All right, let me do an example of the do since we just talked about if. We can see the difference between the two. So I'm going to come over here, make a new program. And call this one, I'll call this one rolling dice. I'll make a dice game real quick. All right, so do I want to take user input for this? I don't know. Maybe I do. Okay, input java.util.scanner. All right, so what I'm going to do is I'm going to, first I need a scanner. Okay, then I'm going to create two die objects. So die 1. All right, so the way the do works, I'm going to make a control variable for the loop. Say I'll call it like end game, and for now I'll just say it's false. All right. The way the do works is like this: you have do, some statements, and then you have your while, and then you have your condition down here. Now, what makes it different from the while is that you're guaranteed to run this code, whatever's inside these statements or these curly braces, at least one time. Right, so you can here you come in here and say system out print line roll dice, right, and we'll just say like, I don't know, 1, 0, and -1. We'll say like yes is 1, no is 2, and quit is dang it, that sucks. It's gonna be super confusing with this. All right, so if they enter -1, I'm gonna quit the loop. If they enter in a 1, I'm gonna roll. Wait, should there be a no? That makes no sense, right? I guess there should only be 2 options, right?
Or just start the loop on the 2 dice that are 1 and 1.
And you want to stay there?
Yeah, because to use the variable like we're doing, it's exactly the same as if you did the while loop. When you use the variable, you have to run at least once. When
Right.
You use when you roll the dice.
Yeah, but like the way that I set up the while is that I didn't actually go into the statement until, like, I had to like set my value first, and then.
Right. But, at this point,
Oh, you're saying to use the integer to control the loop?
you could,
Oh yeah, you're right. I can do something like this, like int user choice, and then use that to user choice does not equal -1. Then that's how I'll control that do loop. Keep prompting them over and over and over, so I don't have to use a control variable. Was that what you're talking about?
no, actually, I was thinking that since you have to roll the dice, you play a hand,
Yeah.
and you want to demonstrate the do while has to run once, you could stop the condition to stop this loop would be a result of rolling the 2 dice and having, I don't know, a given value, like 1 and 1.
Oh, so I just see what you're saying. Like the way we did it before with the while loop, where I didn't end the loop until they're both equal to each other.
Right.
Yeah, yeah, we could do that. But I wanted to do user input, that way I can show, like I'm showing the menu up here inside the loop, where they're guaranteed to see this all the time. And then where if I were to do it in a while loop, it would have to be outside of the while loop. And then you have to ask them again. Like, oh, so I'm doing like this one time, and then I'll show you how it would look if you use the while, just the while loop. So, excuse me. So I'm saying user choice is scan.next int, and then I'll say if user choice equals -1. And game over, right? Here you can actually roll the dice. All right, so I'm printing out what they rolled if they chose to roll, and they're gonna get prompted again. And then everything else, I'll just say like invalid option, right? All right, and I'm gonna make a new line, an extra line like right here. All right. So I'm gonna come over here, clear my screen, Java C, I'm rolling the dice. Dang it, didn't compile. That get base value. I'm just gonna semicolon.
There's a plus,
Oh, the plus is missing. There you go. Thank you. All right. All right. So I like to make sure I can actually leave. Hit -1. Game over. Hit a 9. Invalid option. Bunch of numbers. Invalid option. Fit a 1. Right. 5 and 4. Right. So this is letting me roll over and over and over again until I decide I want to quit after entering -1. Okay, it is a do loop where the statement got executed at least one time, right? So when I ran this the first time, I was able to print it out. Or I could just run it one time where I print out the statement, hit -1, and I quit, right? So this is guaranteed to be ran at least one time. Now, if I was to rewrite this program, I'm just gonna come over here and hit save as, and then rolling the dice 2. This time I'm gonna use a while loop. Instead of using a do while, I'm gonna just use a while. I might have the same condition. Okay, now I have like two. So what's gonna happen here is I have two different things I need to do, right? I either have to like initialize this to not be -1, 0, or I'm gonna have to like prompt them here before they actually start, right? So like that's the difference between the while loop and the do while loop, is you might not even get inside of here, right? Or when I did it with the do, I didn't have to initialize this variable in order to do this check, right? Like if I don't initialize this variable, if I left it just the same, came over here, turn my screen, pile, right? Wait, what the heck? It's happy? Oh wait, that's rolling the dice number 1. Sorry, I'm using rolling the dice 2 that I just created. Right, Java's gonna get mad at me because wait, dang it, I'm messing up. Oh, I ran Java, not Java C. All right, there you go. So it's upset because user choice might not have been initialized. So you have to give it some initial value that is going to be valid so that you can make sure that you actually enter in this loop, right? Because there's no guarantee in a while loop that you'll be able to go inside of here unless this condition here is true. All right, makes sense. Like that's the difference between the two. I don't know. You could use them both interchangeably if however you set it up. I know they're kind of similar, but that's the difference. I don't know. I always normally use a while loop, I guess. But I mean, I guess the do while loop would be, if I know I wanted to do the statement at least one time, then I'll try to use a do while loop. Yeah, any questions on that? That's the difference between the two. I'm not gonna like take off like knowing the difference between the two and using them was something that we did in Java 1. Like whatever one you prefer, the while or the do while, like it's up to you. Whatever loop you want to use is going to be on you. I'm not going to take off points for using one over the other. Okay, but I wanted to demonstrate the difference between the two. The other loop that we have, so it has 3 loops. There's a while loop, there's the do while loop, and we also have the for loop. I'm going to demo the for loop really quick. So I'll come over here, hit save as, I'll put rolling, oh actually I don't want to roll the dice. I'll do for loop demo. Now this is actually created specifically just for iterating through a collection. But it works just like the while loop. Okay, so I'll say public class for loop demo, and then public static void main a string array arguments. Okay, so what I'm gonna do here is what am I doing? say for int x is equal to 0 while x is less than 100, x plus plus. Just do something real simple like that for now. I come over here, clear my screen, and it's a different program. All right, and that's what the for loop does. It's just working just like the while and the do while, even though it seems like it's not, but we can make this just like a while loop, right? So it's guaranteed to, it's not guaranteed to run at all, right? But the way this was set up was you have these 3 spots for statements. You don't actually need any of those statements for this loop to actually run, which is kind of confusing to me. I don't know why it would work like this. You could just come in here and put semicolons and you have an infinite loop, I believe. Hold on, let me make sure. Oh, it's trying to I'm trying to reference x and it doesn't see x anymore. I'll just say loop. I'll say count plus plus, and over here I'll just say count is equal to 0. All right. There, that compiled. It's crazy, right? I didn't think it would compile, but it did. All right, so I'm gonna run, and well, technically it's not infinite, right? Because eventually it's going to reset itself and be negative at some point, right? It can get to the highest possible integer value and then stop, because the next value would be negative. But anyways, you're stuck in this loop. You don't actually need all those statements in there. So depending on your condition, you might not run at all, right? So like I just said, if count is less than -1. So count is 0. It's not less than -1, right? Count's 0 here. The condition check will go in the middle. I'm basically checking to see if count is less than -1. Since it's not -1, or not less than -1, this loop is never going to run. So if I clear my screen, excuse me, compile, and then run, it just didn't do anything because this condition here never became true. So just like the while loop, it might not run at all. Okay. Now the whole reason why this was created was specifically for iterating collections, where we had like this control variable that we wanted to increment, right? Like all this could go inside of this for loop, but I decided to take it out for some reason. But if I said while count is less than 10, this was actually going to run 10 times, right? It ran 10 times because I'm saying while count is less than 10, but like this is my declaration statement. I don't have to have it inside of my for loop, but the way this was designed was that you can slap it in right there, and then my increment step is done right here. I don't have to have it incrementing there. I could just slap it in right there, but I do want to get this value out, so I want to just put that there. Right, so it's kind of set up to where you have these 3 statements. You have your control variable, you have your condition, and then you have your incrementation. Excuse me. Still got that cough. It's so annoying. You still have your incrementation step, but you're putting them all like in this one section. So you don't have like these 3 lines of code that are just hanging out somewhere. Right, they're all put in one area, and it just makes it a little easier to iterate something over a certain number of times. Okay. Now the while loop can be done, like you could do what I did here, you could just do with the while loop. I'm just going to come over here for now. I will comment this out. If I do this with any loop. Okay, the same thing is you just say like int count is 0, and then I'll say while count is less than 10, count plus plus, and then my statement would be to print this out. Okay, it does the same thing as the for loop that I had before. except I'm just taking a little more steps, right? Like the for loops allow us to put all these steps in one spot. All right, and it just, I mean, works exactly the same. So I do use for loops a lot. I mean, whenever I need to like iterate something over a certain amount of time, specifically like containers, like arrays or something like that, or if I know I need to do something like a certain number of times, like ask the user like 5 times for something, right? I'll just use a for loop. But it can all be set up with the while loop, or you can even set up with the do while loop, right? You can, I mean, there's no, there's these 3 loops that we can use. They all have their advantages and disadvantages. But if you just wanted to use a while loop for everything, you could. If you want to use a for loop for everything, you could. Right? We could actually go and rewrite that rolling the dice problem where we're trying to check to see if the number was a certain value. Like we could rewrite the for loop to handle that. Right? And we could do it to where the condition would be this, right? There would be no control variable, and the incrementation would be, there would be no incrementation, meaning it's just gonna stay the same, and your only condition would be that, right? So to prove that, I'll just change this to a 4. There you go, done, right? Slap the semicolon here to say we don't have an initialization step, and slap a semicolon here to say we don't have an incrementation step. All right, that looks kind of weird, but that actually works. If I come over here to my screen, and I run, that was rolling the dice 2, right? Rolling dice 2. Yeah, rolling dice 2. So I'll compile rolling the dice 2. Compiled, right? Crazy. And rolling dice. All right, and then it's just working the exact same. If I hit -1, it will quit. If I hit a 1, it'll roll, a 1, roll. And the reason why this is working just like the while loop is because like the only thing I have is just the condition. I don't have initialization and I don't have the incrementation step.
You're in the wrong program.
Oh, did I?
Yeah.
I thought I said rolling the dice 2. Oh, you're right, dang, what the heck. I compiled rolling the dice 2, but I ran rolling the dice. Thank you. All right, let me clear my screen. Okay, so let me do that one more time. So compile rolling the dice 2. I compiled, and then run rolling dice. Okay, so -1 quits. Works just the same. Wait, dang it, I'm running the same program again. Hold on, there you go. All right, -1, quit, and run it again, and I'll hit a 1 to roll, 1 to roll. Right, it works just the same. Enter in a 9, right, it's gonna tell me invalid option, but I'm still in that loop. I don't really break out until I enter in a -1. Right, so it looked the same, but okay. Yeah. Any questions on that? Crazy, right? You can just use any loop you want. I mean, obviously, I don't know. I think it would be bad programming practice to use a for loop like that. But I don't know. I mean, if that's the way you want to write it, I guess I wouldn't have a problem with it. So that is loops. Okay, so chapter 5, or actually chapter 6. So we have to talk about the switch. Man, the switch is, there's a lot of stuff I want to talk about the switch though. Conditional. All right, so I'm gonna go ahead and stop here, and then the next class, I will finish these 2 right here, the conditional operator and the switch, and then I think that would be it for the review. I mean, everything else would be stuff that I didn't cover in Java 1. So, but we do need to go back to chapter 5 and learn about array lists and iterators, and we already talked about enumerations from chapter 3, right? We did. Okay, cool. And then we also have to go back and talk about all the GUI stuff at some point. But that's all I have. You guys are free to go. If you have homework you want to show me, I know like the way I do my homework is I'm not going to give you a grade until you show it to me. So if you want to show me your homework, you can. I'll be here till 10 o'clock. But if not, you guys are free to go. I'll see you guys on Wednesday.